and there is a person of mass m. There's a small point source, or say loudspeaker, you can put it. There's a trolley of mass m2. The person is initially, the system is at rest. The person, when he jumps with a velocity u r relative to trolley, what are the apparent frequencies heard by him? The loudspeaker will be continuously playing. So when he jumps with a velocity u r, what will be the apparent frequency heard by the person? Find the apparent frequency heard by the person when he jumps with a velocity u r relative to trolley. Where do you brought this? Where it was? Conservation of linear momentum. So the moment when the person makes a jump, what will happen to the trolley? Trolley will recoil. Oh, if you can recollect. So what is the state of trolley? Trolley will recoil with a speed v2. What about the person? The person has made a jump. I think we had some diagrams like this, no? He will jump with a speed ur. So velocity of person will be v1, and the trolley will recoil back. And where the loudspeaker will be fixed to the trolley. Okay, tell me how to get that apparent frequency. Hope you are able to understand the situation here. What is the apparent frequency is asking? Why that apparent frequency will come? Because the sound signal will be generated at frequency f and will be heard at frequency f dash. For that, let's get conservation of linear momentum. Initial momentum is equal to final momentum. Final momentum m2 v2 minus m1 v1. According to the relative velocity, anything directed towards right, I'll take it positive. So minus ur is equal to minus of v1 plus v2. What is the velocity of this? v1 equal to ur minus v2. What is this velocity of the person with respect to ground? That I'll substitute here. 0 equal to m2 v2 v1 ur minus v2. So this will become v2 equal to m1 ur by m1 plus m2. I think you know long back such things. What is the velocity of the person will be m2 ur by m1 plus m2. Now what is v2? Velocity of trolley. What is v1? Velocity of person. Can we apply now the Doppler effect formula? Yes. Now the person will become detected. No, is there any relative motion between the loudspeaker fixed to the trolley and the person? Yes, there's a relative motion. Try to see that as there's relative motion. So now how to write the Doppler effect formula? F dash is equal to F into person moving away from source V minus V1. Source moving away from the observer V plus V2. What is V? Speed of the sound. What is F? Actual frequency. Okay, getting this one. So what are V1, V2? I'll substitute, I'll solve it, I'll get the Doppler effect. So now this Doppler effect is something where you can introduce wherever you want. It's not something, some few set of numericals. Anywhere in the physics can be introduced, provided if source and observer are in motion. This is the apparent frequency heard by person. Okay, these are the some types of numericals is what you should put effort, not only on the pure the Doppler effect one, application of Doppler effect. Doppler effect circular motion, Doppler effect projectile motion, Doppler effect in say like a conservation of unit term, Doppler effect SHM. Any doubt? Any doubt? Okay, we'll take some the interference, some beats one. I'll discuss one problem which is very important. Then I'll go for the other conditions. If there are two sources, three sources are there, we discussed this beats